Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you missed any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you'll be able to access it there as well. And we are taking questions from the audience, although we are not going to have a live Q&A session at the end of this webinar. But please know that the folks at Broadcom will be getting a copy of the questions that do come in, so please feel free to use your GoToWebinar control panel and submit your question at any time during the webinar. And we are doing a drawing at the end of today's webinar for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Enterprise DevOps Series using VS Code and Zowe. Our speakers today are Arnold Diaratna, who is a Research Director of Software Development at IDC, and Rose Sakach, who is Product Manager and Zowe Squad Leader at Broadcom. Welcome to you both. Thank you so much for joining me today. Really appreciate it. Arnold, if you want to go ahead and advance your slide, let's take a look at today's agenda. We have a great webinar on tap. Arnold, I think maybe, there we go. Okay, all right. So here's a quick look at today's agenda. We're going to be taking a look at some of the developer trends and their DevOps impact, as well as some of the enterprise DevOps enablers. And I believe that Rose is going to be talking about a use case with onboarding next-gen developers. So a really, really interesting webinar on tap for us. So Arnold, I know that you are going to be kicking off the conversation. So I'm going to put myself on mute and let you get right to it.
Thanks, Charlene. The topic of our presentation today is development trends and DevOps impact. And specifically, we'll begin with some remarks on developer influence and responsibilities. This slide quantifies the contemporary proliferation of developer responsibilities and specifically reveals that developers spend less than 20% of their time writing code, as you can see in the second set of bars here. The slide compares data from 2019 to 2020, where 2019 is depicted in orange and 2020 is shown in blue. And one thing that's striking here is that the data spanning these years is remarkably consistent. Focusing on 2020, our finding is that developers spend 17% of their time writing code and a total of 46% of their time writing requirements, working on software design and architecture, and developing applications. This means that developers spend more than 50% of their time on operational responsibilities, such as CI/CD, monitoring, testing, security, and user experience. So some key takeaways here are that, once again, developer responsibilities have expanded to the point where developers are not only designing and developing applications, but are also increasingly engaged with business stakeholders with respect to requirements, elicitation, and definition. And so are involved not only in development, but also in the conceptualization and definition of the product. Secondly, the slide shows the shift left phenomenon in DevOps on full display here, where developers are increasingly responsible for managing the implementation of automation with respect to applications. And finally, as demonstrated by the focus on user experience, developers are also focused on the reception of application by by end users. So despite the proliferation of responsibilities that we saw in the previous slide, our finding here is that developers want to spend more time coding and less time on operational responsibilities. This slide illustrates activities that developers want to spend more time doing in orange and those that they want to spend less time working on in blue. And as you can see here from the second set of bars from the far left, 44% and 46% of developers want to spend more time on application design and coding, respectively. Meanwhile, 36% and 32% of developers noted that they wanted to spend less time on debugging and bug tracking. Additional observations are that 38% of developers are interested in spending more time on requirements analysis. And that having been said, one of the other things that's interesting is that roughly 35% of developers are interested in spending more time on testing. The larger point here is that given the opportunity, developers would love to spend more time on higher level activities related to application design and development. That having been said, it bears worth noting that developers are interested in spending more time on a multitude of discrete responsibilities beyond development and application design, such as testing and even debugging and bug tracking as well. So speaking of automation, developers noted that automation, and specifically a lack thereof, was the principal inhibitor to developer productivity. In other words, the principal inhibitor to developer productivity was a lack of automation with respect to collaboration, software development and deployment, and IT operations. Developers feel there are opportunities to increase automation in the development experience, both with respect to the ease of collaboration with peers, as well as the minutiae of development and the operational management of applications and the infrastructure on which they run. Interestingly, more than 30% of developers did cite other factors as relevant to developer productivity, such as talent, resource management, and self-service capabilities. So to summarize, from a technology standpoint, developers feel that lack of automation and self-service capabilities are the principal inhibitors to improve productivity. Turning to developer tools and DevOps adoption, this slide illustrates the top 20 languages used by developers worldwide. The area of each square corresponds to the number of developers who use this language at the level of heavy usage. And the purpose of this chart is relational in the sense that it allows us to quickly compare the number of developers who use each language by looking at the size of each rectangle or square. What's notable about this slide is its illustration of the way in which contemporary developers leverage a multitude of languages. So even though it's the case that Java and JavaScript are the two most popular languages worldwide, as seen in the light blue and dark blue on the far left, developers use several other languages as well, such as Cobalt, for example. As such, the contemporary development landscape is fundamentally polyglot in nature. This slide illustrates the growth of cloud-based developer tools in contrast to on-premises developer tools. And what's worth noting here is that in a market landscape sized at 4.3 billion, cloud-based developer tools are growing with an annual CAGR of 17.4% through 2024, whereas on-premises dev tools are growing with a CAGR of 1.8%. And so, given an overall market that is experiencing growth of 3.2%, cloud-based dev tools such as Eclipse Che and GitHub Codespaces are responsible for leading the growth of the developer tools market. Post-pandemic, or in this pandemic era, cloud-based developer tools have been especially important because of their enhancement of developer agility and their enablement of accelerated developer velocity. Developers need not worry about installing cloud-based development tools on their local machine, and instead can use these tools from any device that can access the internet. This ability to access work from a browser minimizes the operational hassle of configuring local environments and instead empowers developers to do something that they're highly interested in doing per our previous discussions, namely to focus on writing code. So continuing with the themes of automation and developer velocity, this slide illustrates the growth in the adoption of DevOps, and specifically growth in adoption from 68% in 2019 to 81% in 2020. Just to level set, DevOps for IDC refers to a set of development methods that promote agile, continuous application code delivery, automated self-service infrastructure delivery, and close collaboration across lines of development and business and IT operations roles. This is a really remarkable increase that we see here, and it represents a larger increase in DevOps adoption between 2018 to 2020 of 52% to 67% to 81% respectively. Of course, this doesn't mean that in 2020, 81% of application estates leverage DevOps. It does mean, however, that 81% of enterprises worldwide are using DevOps, and by extension, that DevOps has become mainstream. This slide continues the conversation from the previous slide about DevOps adoption by addressing how specific DevOps practices have been adopted both in 2019 and 2020. The key takeaway here is that looking at DevOps practices such as pair programming, continuous integration, continuous delivery, automated testing, and automated code quality analysis, as shown on the x-axis, we see a significant year-over-year increase in adoption across the board. The one exception, if any, is self-service provisioning, which is adopted less strongly in 2020 than the other modalities of DevOps. The point worth noting is that the adoption of DevOps in recent years has been multivalent and broad in scope. DevOps adoption has not been fundamentally driven by CI or CD, but more broadly by adoption of development practices that increase automation in the development experience. This slide shows how DevOps implementation makes everything go faster by quantifying the effect of DevOps implementation on the frequency of deployments to production. In this case, orange refers to post-DevOps implementation, while blue refers to before. And the slide shows how post-DevOps implementation, turning to the rectangle at the top with the the weekly and every two to 3 week and monthly cadences, there is an increase in deployment frequency for these deployment cadences, and correspondingly, the deployment frequency for the every 2 to 3 month and every 4 to 6 month and once a year cadence decreased. So once again, the point here is that the adoption and implementation of DevOps makes everything go faster, and specifically here in this context, the frequency of deployments to production. So with that, I'll turn it over to Rose, who will discuss enterprise DevOps enablers.
Thanks, Arnold. Do you have this one more slide, maybe?
Oh, actually, I have one more slide. I'm sorry.
Okay.
And just to conclude, this slide illustrates the influence and freedom that developers have regarding the selection and purchase of developer tools and cloud adoption. So developer influence is depicted in blue, and developer freedom is shown in orange. And predictably, developers feel that they exercise the most influence over the purchasing of IDEs and decisions about the use of development languages. That having been said, what's also striking is that developers feel that they exercise influence over other attributes of development, such as cloud adoption and cloud vendor selection, and even decisions about legacy application modernization. In addition, turning to the segments in orange, what's striking here is that developers feel that they have freedom and autonomy with respect to the selection of developer tools and infrastructures as the case may be. And that's characteristic of pretty much everything on the y-axis, inclusive of IDEs and languages, all the way up to development frameworks and even build tools. So once again, thank you, and I'll turn it over to Rose.
All right. Thanks, Arnold. Can you hear me okay? Yes?
Yes.
Okay, super.
Yes, I can hear you. Sorry.
Excellent. Okay. So I'm going to guess most of the statistics that Anil, you shared with respect to developers and DevOps don't come as a surprise to anyone joining us today, but perhaps some of them do. Developers spending like 80% of their time doing something other than writing code was a surprise to me. But the increase in the adoption of DevOps practices, DevOps being mainstream, developer influence on their own and enterprise tool selection, and their desire to increase automation to improve productivity definitely aligns with what we've been seeing for sure. So let's transition the discussion to talk about how we can enable these. Right. So as organizations look to further their DevOps initiatives to incorporate mainframe assets, they uncover several challenges that are unique to mainframe. When we examine today's mainframe developer experience, it continues to be primarily based on the linear waterfall development methodology with traditional ISPF-based tooling, which was not necessarily engineered for speed. And the Eclipse workstation-based experience, though richer than green screen, is considered to be outdated. Developers learn, embrace, and tend to become attached to integrated development environments, their IDEs. And I can tell you, as a prior application developer, I completely understand and have an appreciation for this. So we do understand many developers love ISPF and others love Eclipse, and that's great. but there are new tools that a contemporary developer knows very well and loves. Let's try to visualize how most cloud, mobile, and distributed developers work on a given day. First, they're spending most of their time in their code editors with SCM repos. I say with because if we're talking VS Code, it's Git native and easily allows the addition of any number of extensions that offer support for various aspects of their job. For example, programming languages. There are VS Code extensions out in the marketplace that target and make it easy for Java developers. The most often a developer will, they'll go out and look for an extension that specifically supports a coding language. And that extension offers features like syntax highlighting, code completion, and some form of samples or code snippets. And developers will continue to shop for other extensions to help make them as efficient as possible. This enables them to build their own cockpit, if you will, to suit their specific needs and preferences. It actually becomes quite personal. The developers are also incorporating desktop automation, automation tools like Gulp, Jest, Jenkins, and they use them by invoking them either directly or through the use of scripts. Sometimes they'll write the scripts themselves, other times they're written by others and made available to them. It's very common for team members to share automation scripts. But to incorporate these tools for mainframe development, we need to be sure the framework is in place, the framework under the covers that enables the interaction between their desktop and the mainframe. By now, I'm sure you've heard about the open mainframe project Zowe. Zowe is that framework that has enabled the connection between the developer desktop, full of their own preferred extensions and automation tools, and mainframe native tools like CA Endeavor. The Zowe command line interface allows developers to unite mainframe actions with desktop automation through build scripts that leverage tools like, for example, SonarQube for code scanning. And this creates something that we have labeled here as the autopilot automation experience. So yes, the high velocity tool chain really can work beautifully for mainframe development as well. Essentially what this all means is that it's true, Git native IDEs are in fact mainframe ready. Whether you prefer the lightweight Visual Studio Code, as close to 11 million users do, or the container native web version of it called EclipseJ, mainframe developers now have the ability to gain the benefit of creating their very own cockpit. And we've made it a bit easier for developers who may be wondering which extensions they should incorporate for the most efficient mainframe experience. What we did was we created a code pack by grouping together a number of extensions. Think of it like a starter kit. We call it Code for Z at the Visual Studio Code Marketplace. And we call it J for Z at EclipseJ. Like Zowe, these packs are open source initiatives led by Broadcom. Both are free, both are Git and Zowe enabled. As I mentioned, Zowe plays a major role in enabling this mainframe-ready Visual Studio Code experience. The service-oriented API-driven Zowe framework opens the mainframe to off-platform orchestration and automation tooling. Here's why this is important. It renders the mainframe as no different than any other IT platform from an app dev perspective. So just like cloud, mobile, and distributed platforms, mainframe can participate in CLI, API, script-driven development, and leverage the long list of modern DevOps tooling sitting on the developer's desktop. while at the same time also interacting with the mainframe. The simplest and most popular example is that mainframe developers can leverage Zowe CLI to script the checkout of a mainframe asset and invoke a code scanning tool using their own Jenkins CI/CD pipeline. The mainframe actions necessary to make this happen simply get incorporated into a script. The CA Endeavor Bridge for Git also plays a role in enabling this experience. As the leading mainframe SCM, Endeavor serves as the enterprise repo for millions of mainframe software assets, their interrelationships, and their build parameters. While Git is foundational in the contemporary developer's cockpit, the Bridge for Git is a must, and it is actually named quite appropriately. Let's go back to the developer cockpit that we looked at. Given contemporary developers the ability to interact with Git has essentially become table stakes. They expect their code to be there, but how do you get it there? Well, rather than lifting and shifting all of your software assets to Git repos, which introduces an extraordinary amount of risk, Bridge for Git retains Endeavor as the main repo while enabling developers to use a Git front end to interact with it, essentially creating a path or a bridge behind the scenes. Most organizations use one of these 4 commercial enterprise Git servers: GitHub, GitLab, Bitbucket, Azure DevOps. The Bridge for Git supports all of them. Here's an added benefit that you may not realize. While Git Bridge allows developers who know and love Git and VS Code to use it for their mainframe development, at the same time, it allows veterans who love Endeavor and either ISPF or Eclipse, allows them to continue to use them. This is essentially the best of both worlds. Regardless of what the developers choose to use, they can collaborate on the same code base in real time with Endeavor serving as the main code repository. Bottom line, your mainframe investment is protected and your veterans remain productive, all while enabling a contemporary experience with the new standard Git. Now let's show you what this looks like. All right, so this is day 1 for our new to mainframe developer, Michelle. She's a Gen Z with no hands-on experience with mainframe. Her background indicates she has an understanding of Cobalt from the Open Mainframe Project Cobalt course. She's also part of a Scrum team that supports a mobile to mainframe application and has been tasked with resolving a common mainframe issue. To set the stage for her preferred development experience, her manager recommends some tools for her VS Code cockpit, including several VS Code extensions, Git CLI, and several scripts. Remember that autopilot experience mentioned a few slides back? Michelle's team uses a set of scripts for performing tasks like build, deploy, and test. These scripts connect to the mainframe to perform typical mainframe functions, perhaps to obtain the source and build parameters for her program, for example. And while at the same time, interact with desktop tools like Jest for testing and Jenkins for CI/CD. Quick checkpoint quiz for all of you. With these two characteristics, meaning interact with the mainframe and desktop tools, what does this tell you about these scripts? Exactly, Zoe's involved. All right, so here's a look at Michelle's VS Code Git-powered cockpit. Let's see what she's using, why she's using it, and let's give you an understanding of what's happening behind the scenes. So first off, this is not green screen, it's not ISPF, and it's not Eclipse. This is VS Code. Michelle is instantly comfortable with this setup. She begins her task by looking at the program. Right out of the gate, she sets up her view to get a high-level overview of the program. She starts with the Cobalt control flow extension to get a feel for how the Cobalt program is constructed. How many paragraphs are involved? How deep is the nesting of paragraphs? The control flow is something Michelle can easily add to her VS Code editor because it's a VS Code extension. It's searchable and it's available right from the VS Code marketplace. She took her manager's advice and added it. Essentially, it allows her to view Cobalt paragraphs as an interactive graphical node. This is a great visual for any developer needing a very quick understanding of a Cobalt program. What she's done is she's moused through several nodes and has settled on a node which takes her tab or view of the Cobalt program to a particular paragraph where the problem is likely to occur. Behind the scenes, this is pretty straightforward. The Cobalt control flow is a self-contained extension. There are no additional client-side or mainframe services involved here. Okay, now that Michelle has a general understanding of the program flow, she's going to tap into the features provided by the Cobalt language support extension. She found this free extension at the VS Code marketplace and installed it before beginning this task. This is another VS Code extension. Since she's new to Cobalt, she's going to leverage this quite a bit. She relies on the autocomplete feature, particularly with field references. For example, working storage fields are presented to her to help prevent her from referencing undefined fields. And she'll also be using the highlighting feature to verify if, for example, the if then else clauses have not been compromised with her change. The real-time syntax ensures she doesn't forget the simple things like a period after a paragraph name or uncommenting statements by accident. Cobalt language support is going to give her confidence that as she modifies the Cobalt code, the changes she's made are syntactically correct. And for all of you seasoned Cobalt developers, this means your compile is probably going to work the first time you submit it. That would have been cool for me many years ago. Behind the scenes, the extension leverages a language server client, which in addition to Cobalt, supports many of the languages that are now mentioned earlier. This same protocol is also used in Eclipse J, GitHub Codespaces, and other next-gen IDEs. Okay, as Michelle prepares to test her program change, she'll need to edit some data sets and submit jobs in the mainframe. The Zowe Explorer is our third VS Code extension. The Explorer is the most popular Zowe component with more than 20,000 downloads. In our case, Michelle will use it to edit mainframe data sets, to prepare JCL, submit, and review mainframe jobs. She won't need it this time, but if she had to work with them, the Zowe Explorer would allow her to view and modify even USS files. Behind the scenes, what's going on? Zowe Explorer is part of Zowe. It's a Zowe VS Code extension on her desktop. It leverages the Zowe API mediation layer on the mainframe. The API mediation layer has cataloged and authorized the use of the ZOS management facility. We usually refer to this as ZOSMF. The mediation layer, again, has cataloged it and authorized her to use it, use the RESTful API, the service that is ZOSMF. Michelle doesn't need to know what's happening between her desktop and the mainframe. All she really does is use that extension. Next, once Michelle completes her initial code change, she wants to be sure her change gets migrated to test areas and ultimately to production in the repository of record. If she were a mainframe veteran and preferred to interact directly with Endeavor, Michelle could use the Endeavor extension. But because she's new to mainframe and already knows Git, her manager suggested using the built-in Git extension in her VS Code editor, which allows her to issue Git commands: git init, git clone, git commit. She will find Git over in her activity bar on the left. She'll use standard commands to save and stage her change for deployment. Initially, she'll do it on her enterprise Git server, which automatically synchronizes with and pushes the change through the CA Endeavor lifecycle. Now, behind the scenes, when Michelle issues a Git command, the local Endeavor bridge for Git calls the Zowe API mediation layer on the mainframe, which again has cataloged and authorized the use of the CA Endeavor REST APIs to perform the Endeavor actions. Michelle doesn't need to know all of that, as we said before. She simply issues Git commands like she always has for any of the other platforms she's worked on. Once Michelle is satisfied with the code change, again, just like she would do with any other platform, the next steps are to build, deploy to test, and run some tests. Here's where she'll find something else she's very familiar with using: automation scripts. Her team has 3 pre-built DevOps scripts that her team lead has shared with her. If you look over in the lower left in the navigation area, you'll see the 3 scripts: compile link, deploy to test, and just dev test. She'll click on the first script to perform the build for her Cobalt program change. We know this as the compile and link. She'll click on the second script to ensure the executable produced from the build is copied over to a load library available for the testing framework. This could be copying over to a specific batch load lib or a particular CICS region where the test is being run. And then finally, she'll run the third just dev test to invoke a script that leverages the just testing framework, pre-built to run a series of tests designed to validate this particular application Michelle is changing. After she executes each script, she'll use the panel in the center area at the bottom to view the terminal output condition codes. In this case, you'll see that Michelle's compile link script invoked a Zowe Endeavor generate command. What is actually happening here? Well, the script leverages the Zowe CLI plugin for Endeavor, which calls the Zowe API mediation layer on the mainframe, which, and by now you've got this, the API mediation layer houses the Endeavor REST API service, which ultimately invokes the Endeavor generate or build actions. Again, Michelle is shielded from all of the complexity and simply waits for her build to complete and reviews the log at the bottom of her view. The scripts could be coded to leverage any number of tools for Michelle's test. She happens to be leveraging the Jest testing framework, but she could use Mocha or something else. The scripts could also use CI/CD tools like Jenkins. This is Michelle's final step for her day 1 assignment. Once the change is tested and she confirms the results are good, her day 1 task is done. So in conclusion, our Broadcom VS Code and Zowe DevOps enablers, they create an experience that is familiar, desirable, comfortable, and trending in growth for contemporary developers, setting them up for success right out of the gate. They also allow mainframe veterans to remain productive while they're onboarding new developers to their team. They align with enterprise DevOps initiatives, meaning they allow organizations to incorporate mainframe with existing enterprise DevOps, which have shown a steady increase in automated practices ranging from CI/CD to automated testing to code quality scanning. They are open source driven and as such are a zero cost modernization option. Finally, they ensure the vitality of the mainframe. These enablers reframe the mainframe to be no different than mobile, cloud, and distributed platforms for contemporary developers, essentially breaking down app dev silos while retaining core mainframe attributes. So what's next for next gens? Another way of saying this is, but wait, there's more. There are many more extensions out there for Michelle. If she has a need to leverage more powerful debugging capabilities, she might add more VS Code extensions. For example, the debugger, the mainframe debugger, is a more powerful tool that leverages the DAP or debugger adapter protocol and CA intertest. If she's assigned to support an application with critical batch workloads and she needs to quickly become an expert at job control language, she may go grab the JCL language support extension, which provides both standalone capabilities as well as extended capabilities with the CA JCL check product, including a linting experience and some code snippets. If her application leverages vStemp files, she'll want to go grab the dataset viewer for quick and easy data viewing and data manipulation. Or she may just add more Zowe CLI plugins like the ones for Kix and DB2, or for other mainframe business application tools like ZOS Connect. And finally, for those serious about mainframe DevOps and mainframe modernization, we highly recommend an open-first approach with tools like VS Code and Zowe. As a trusted mainframe partner, we're ready to support your efforts, which is why we offer CA Brightside. In addition to enterprise-grade support, simplified installation, and IP assurance, it includes exclusive access to commercial add-ons, as well as all of the Broadcom product Zowe V1 conformant CLI extensions. That list is currently at 12 and still growing. We also include support for all of the extensions included in the Code4Z code pack available at the VS Code Marketplace or the Eclipse Foundation EclipseJ website. If you like what you've seen today and you're ready to empower developers to spend more time coding, please do take a closer look at CA Brightside. Thank you for your time today, and Anil, it was an honor and a pleasure to present with you. Back over to you, Charlene.
All right, great. Well, thank you very much, Rose. As I did mention at the top of the hour, we would not be doing a formal question and answer period during today's webinar, but the folks at Broadcom will be getting a copy of all of the questions that do come in. So please feel free to go ahead and use your GoToWebinar control panel and submit your questions, and we will get them over to the folks at Broadcom for following up with you offline later post-webinar. I did mention at the top of the hour that today's event is being recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, also at the top of the hour, I did mention that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do those. Our first winner today is Elena T. Congratulations, Elena. Our next winner today is Elisa M. Congratulations, Elisa. Our third winner today is Joel H. Congratulations, Joel. And our fourth winner today is Terry E. Congratulations, Terry. We'll be following up with all 4 of you offline by email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything in your inbox, please check your spam folder. I do want to thank Rose and Arnold for a great presentation today. I do appreciate your expertise and all the information on the Zowe project. Good stuff all the way around. So thank you again to both of you. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am now signing off. Have a great day, everybody, and please stay safe.